So I'm guessing it's something about the delocalization
Of what?
of the what do you call it? The lone pair from the NH2 group.
Okay, so what about it? When we talk about basicity, so what affects the basicity of what affects the basicity of a phenol amine in this case? So,
The
what
position,
does, yeah,
the
okay.
position of NO2.
Really?
Okay.
Oh, okay. But my question goes back to what affects basicity? What makes it basic? What makes it basic?
The power for it to accept the proton group.
Okay, so it can accept
Yeah.
a proton because it has a
Yep.
lone pair. Okay, so depending on which one is more basic, so to decide which one is more basic, you have to think which one has the lone pair more available to accept a proton. Do you agree?
Yeah, yeah.
Okay, so you talk about delocalization. Can you visualize it, or do you want to draw it out and then you can tell me? So which one has the lone pair more available to accept protons? You talk about delocalization, but it's
Yeah.
very hand waving. Can you specify exactly what you're thinking or what you're saying? You can't just say delocalization like that. You have to go from there and then you have to extend the idea further.
Mm,
Anything?
no clue.
No clue at all? Cool.
Yeah.
Can you draw? Okay, I'm gonna instead of drawing the ring, I will draw the cocoon structure with the alternating double bond. Okay,
Yeah.
it will be easier for you to see. Can you draw the cocoon structure, but showing the display form at the NO2?
Okay.
So cocoon structure of the benzene ring, but on the NO2, can you display the bond so that I can see what you have drawn?
Wait, sorry.
No, the cocoon structure is okay, but cocoon structure you don't have to show the carbon, so just show the benzene ring but with
Okay.
alternating. Because once you show the carbon, then it looks weird. And also, I want you to display at the NO2. I want you to show all the bonds at the nitrogen containing the NO2, only at the NO2, because that one is important.
Okay.
Because the only thing that's different is the position of NO2 here, right? So it must be to do with that. Do you know how NO2 looks like?
Yep.
Okay. Once you have drawn it, show it to me, and then so that I can see whether you got it okay or not. Nope. That is not okay. That is not okay. Do you know how an NO2 looks like? So you never seen an NO2 before, and there's a big problem, okay?
Oh.
So there's a nitrogen plus, by the way.
Yeah.
The nitrogen has 4 bonds. So it's a NO2. Overall, it's neutral, but it's got a plus on there. Okay? Can you draw for me another molecule? Can you draw for me HNO3? Display formula for HNO3. Do you know what HNO3 is?
Yeah, nitric acid.
Okay. Are you able to draw the display formula for HNO3?
Wait, let me try. NO. I don't know.
Okay, it's an acid, so there's a H. That H is bonded to a O, single bond, and that O is single bond to a N. And then it's a HNO3, right? So one of the O is single bond. So have another double bond oxygen to the nitrogen, and then have another single bond to another oxygen. But because that nitrogen is now 4 covalent bond, so it must have a charge. What charge must it have?
Plus.
Yeah, because it's got 4 covalent bond now, right? Okay.
Yeah.
And then that single bond oxygen with nothing bonded to it must be a
negative.
Can you show me your nitric acid now? That is wrong. I said get the final. Oh my god, no. You have drawn charges on the oxygen when the oxygen has 2 bonds, and that is not the way to go. So you already have problem with your charges in structure of molecule, yeah? There's HNO3.
Oh, okay.
Yeah, your structure is already wrong partly because you have a O minus on a oxygen, which is two covalent bond. When oxygen forms 2 covalent bond, it retains 2 lone pair and it doesn't have any charge.
Yeah.
And it doesn't make sense anymore, okay? Can you draw for me sulfuric acid?
Sulfuric acid. H2.
It's very easy to see the formula, right? But it's not so easy when I ask you to draw it. Unless you know what you're talking about. It's the same idea again. It's got two acidic group, so it's got 2 of the H bonded to oxygen. So basically, it's an OH on one end, it's another OH on the other end to the sulfur.
Okay.
What group is sulfur in? What group is sulfur in?
6.
Okay, so you should have 6 outer shell electrons, right? Then you should decide what to do with the other 2 oxygen.
Yeah. Okay. Double bond OH. 6. I don't know.
Yeah, that's correct. There's H2SO4. So once it lose 1 proton, then you will get the conjugate base, which is HSO4 minus. And then you can lose another proton because it's diprotic or biprotic, some people call it. And then you become SO4 2 minus, which is a anion. What is the shape of SO4 2 minus? So on that structure of sulfuric acid, when you lose 2 of the proton, then you get an O minus and O minus.
Yeah.
SO4 2 minus. Where's the shape of that ion?
Oh, you mean the shape?
Yeah, what's the geometry about the sulfur?
Trigger. Wait.
Look at the structure. Look at the sulfuric acid that you draw. Okay.
The structure for SO4.
Oh, SO4 2 minus. When you lose the 2 proton, then you get the ion SO4 2 minus, right?
Yeah.
What is the shape of that ion? And tell me how you got it. Or you can tell me how you got it, and therefore you can tell me the answer after that. It's up to you.
The shape?
Have you done shape of molecule?
Well, so I would it be
geometry?
Tetrahedral?
Are you telling me or are you asking me?
That's telling you. Tetrahedral.
Oh, right, okay. If you're telling me, then you wouldn't say like, is it something like that? Because you'd be quite certain of your answer. And how? Explain to me how you would come about that response.
Because it's bonded to 4 different atoms and it does not have any lone pair.
Okay, so you can only tell that
The sulfur.
because you know that sulfur is in group 16 or
Yeah.
group 6. You said. Otherwise, it will be impossible for you to know what is going on there, right? And you won't have predictable. I mean, these are common elements which you should know where they are. Yeah? Okay,
Yeah.
how about the nitrate ion?
Nitrate ion.
So from the nitric acid, when you lose a H plus, you don't even need to lose a H plus. Geometry doesn't change, right? When you lose a
Yeah,
proton.
yeah. For this one, I'd say it would be wait. So there's a lone pair on the nitrogen, so I think it will be a V shape.
V shape. So what's the bond angle?
104 degrees.
Okay, can you draw for me your nitrate and ion? Can you draw for me nitrate and ion?
NO2.
Nitrate. So nitric acid, when you get deprotonated, what do you get?
Wait, what? Sorry. The nitric acid.
When nitric acid, HNO3, gets deprotonated, you get an anion called nitrate anion, NO3
Yeah.
minus. Can you draw for me NO3 minus, the display form? I don't need the dot and cross. No one does dot and cross.
Okay. Wait, I haven't fixed. So, N double bond O. Oh, sorry. Yeah, I think the shape is different. Sorry.
Oh,
Because
really? Oh, okay.
I was referring to the wrong one just now, the old one.
Okay. You were referring to the wrong one. Okay.
I
Cool.
did
All right.
change.
Okay. So tell me what's the shape then?
So, trigonal planar.
Why is that?
Trigonal planar.
I know, but how do you come about that decision?
Because nitrogen is bonded to 3 different atoms, and it does not have any lone pair. I think. Yeah, it does not have any lone pair.
So basically, you're saying there are 3 bond pair. It's not just bonded to 3 different atoms. There are 3 bond pair, 0 lone pair, 120-degree trigonal planar. Yeah. Okay. Cool. Going back to the nitro group, the NO2 group there. Okay. So the nitro on the benzene ring. What is the geometry about that nitrogen of the NO2? What's the shape at that nitrogen? You have the NO2 on the benzene ring, right? What is the shape at that nitrogen of the NO2?
Sorry, so your voice cracking.
Okay, going back to that benzene question, phenylamine question. Yeah, phenylamine. Okay.
Yeah.
So the nitro group, the NO2 is on the
It's very like
phenylamine. So what is the shape at that nitrogen on the NO2 group? So you have an NO2 on the benzene ring. What is the shape at the NO2?
trigonal planar.
Yeah. Okay.
Yeah.
And the benzene ring is planar itself, right?
Yeah.
So can you see the NO2 is in the plane of the benzene ring?
Yeah.
Yeah. Okay, cool. And what do you know about phenylamine basicity? In A level, you know that the lone pair can get delocalized into the benzene ring, right?
Yeah.
And therefore it activates the second position and the fourth position because it delocalizes the lone pair into the ring. And it also explains why phenylamine is less basic than ammonia because the lone pair is essentially not very much available because it's delocalized into the benzene ring, right?
Yeah.
Okay,
yeah.
cool. So now with the Cocoon structure and the NO2 shown as display, are you able to push and see the extent of delocalization when the NO2 group is at position 3 or position 4 relative to the NH2? Can you push arrow?
What was that? Sorry.
And see where the lone pair can get delocalized to?
Sorry, can you repeat? Sorry, it's lagging.
So the lone pair on the NH2, are you able to use curly arrow or what we call pushing arrow to show how that electrons get delocalized through the pi network of the benzene ring as well as the NO2? Compare the extent of delocalization between the two. You can decide which one is more delocalized.
Using the
So
cursor.
yeah, because it's a lot easier to move the double bond around. It's easier for you to follow. Once you've done the first step, show me so that I know what you're doing.
Okay. Let me draw first. NO2. Draw the NO2 as well.
So I've got things like that. There's the cuckoo, right? And the NO2. Happy?
Yeah.
Okay. I've got the lone pair on the NH2, right? I will show you the first step. I'll show you the first step. I push arrow into the benzene ring. I push arrow into the benzene ring. Yeah?
Yeah.
Wait, what do you think will happen next? Where is the next arrow going?
Going towards the...
Do you want to draw yours and then I can see?
Yeah, I'll draw mine.
Okay. So I just want to see how okay you are with arrow pushing. You got a second arrow for me already?
Oh, yeah.
Nope. your lone pair doesn't go into the carbon straight away. Your lone pair goes to that carbon on the benzene ring. Look. You are attacking, you are donating that electrons into that so that you will form a double bond there.
Right.
And this is a double bond there. So what will the double bond do? That carbon already formed 4 bonds. So now you are forming a new bond. Therefore, this double bond must break. It will go there. Do you follow the first step?
Yep.
Okay. Your first step is already wrong. Your first arrow is already going to the wrong way.
Okay.
Look, the idea is delocalize lone pair into benzene ring. Into benzene ring. Not to the side of the benzene ring, into. Yeah? This nitrogen is bonded to this carbon, so it donates into that orbital first.
Yeah.
What is the next step? The next step is do you see the second arrow? The double bond move its electron to the other side. Can you see that? Can you see the second arrow? Hello? 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 Can you see the second arrow? Can you see the second arrow?
Sorry, can you repeat? Sorry, your voice is cracking.
Can you see the second arrow or not?
Yeah, now it's okay.
Okay, cool.
Hello?
So do you understand why the second arrow is moving that way?
Hello?
Hello? Can you hear me?
Hello?
Hello? Can you hear me?